begins in silence, a profound, absolute quiet that humanity has never truly known. Here, suspended in the velvet abyss beyond the last whispers of our solar system's influence, a vessel waits. Its designation is Explorer 25P/70. It is less a ship and more a sliver of thought, a needle threaded with the light of human curiosity, poised to be cast across the grandest tapestry of all. Its mission is an act of sublime audacity, to journey through every major galaxy in our observable universe, not merely to catalogue, but to experience, to witness the full, breathtaking diversity of cosmic creation, from our doorstep to the dawn of time itself. The command is given, a stream of logic across the void, and with a distortion of space-time that is not a propulsion but a folding of the fabric of reality, our journey starts. Before us, our home, the Milky Way. From this vantage point, it is no longer the faint dusty band we see from Earth's surface. It is a spinning, incandescent pinwheel of impossible scale, 100,000 light-years from edge to edge, a celestial metropolis of 400 billion stars. We see the majestic spiral arms, great rivers of gas, dust and newborn suns, unwinding from a brilliant central core. These are the Perseus and Scutum Centaurus arms, luminous with the furious blue-white light of young, massive stars. Our own sun is an insignificant speck, tucked away in a minor spur called the Orion Arm, a quiet cosmic suburb. We plunge towards the galactic heart. The density of stars increases exponentially. What were once pinpricks of light now merge into a continuous blaze. We pass through globular clusters, ancient spherical collections of the galaxy's oldest stars, orbiting the core like ghostly satellites. These are stellar fossils, born when the universe was young, their red and gold light a testament to unimaginable age. The very air of space-time hums with gravitational energy, and then we arrive at the centre. A churning, chaotic region of gas clouds and stellar torrents. At its very heart, hidden behind impenetrable veils of dust, is a monster, Sagittarius A star, a supermassive black hole, 4 million times the mass of our Sun. We cannot see it directly, we see only its influence. Stars whip around an unseen point at incredible speeds, their orbits a frantic dance around a gravitational overlord. This is the anchor of our galaxy, the silent engine around which our entire stellar city revolves. It is a place of both ultimate destruction and profound order. Having paid homage to our galactic core, we turn outwards. Our vessel accelerates, reality bending to our will. The Milky Way shrinks behind us, its glorious spiral form becoming a single, beautiful object against the black. It looks peaceful from this distance, a placid island of light. But we know the truth. We have just left a maelstrom of stellar births, deaths, and cosmic violence. A reminder that the universe's beauty is often forged in fire. Our first interstellar destination is 2.5 million light-years away. Across this chasm of intergalactic space, a faint, fuzzy patch of light grows steadily larger, more defined. This is Messier 31, the Andromeda Galaxy, our nearest major galactic neighbour and our destiny. It is a titan, larger than our own Milky Way, containing perhaps 1 trillion stars. Its spiral arms are more tightly wound, its central bulge more prominent, glowing with the yellowish light of older stars. It approaches us at a staggering 110 kilometers per second. Imagine 2 vast cities, each with billions of inhabitants hurtling towards each other through the night. For now, the distance is immense, the collision a far future event. But from our accelerated perspective, we can see the inevitable. In about 4.5 billion years, these 2 great spirals will begin to merge in a cosmic dance of breathtaking grandeur. Tidal forces will stretch and warp them, flinging great streamers of stars and gas into the void. The night sky of a future Earth, if it still exists, will be dominated by this celestial cataclysm. It will not be a collision of stars, space is too vast for that. Instead, it will be a gravitational merger, a slow, majestic process that will birth a new, even larger galaxy, already nicknamed Milky Way. We sweep through Andromeda's outer halo, a sparse sphere of ancient stars and dark matter extending for millions of light years. We pass its own satellite galaxies, Messier 32 and Messier 110, small stellar systems gravitationally bound to the larger entity, like moths circling a colossal flame. One is a compact elliptical, the other a dwarf elliptical, showcasing the different evolutionary paths galaxies can take. They are testaments to Andromeda's gravitational dominance. Leaving Andromeda, we pivot towards the third largest member of our local cosmic family, the Triangulum Galaxy, or Messier 33. It's a beautiful, less organised spiral, a flocculent spiral, meaning its arms are patchy and ill-defined. It is a hotbed of star formation, its arms studded with enormous glowing pink clouds of ionised hydrogen. These are stellar nurseries, regions like NGC 604, one of the largest known, where thousands of massive new suns are igniting. Triangulum feels younger, wilder, less settled than Andromeda or the Milky Way. It is a glimpse into a more chaotic cosmic past. Our local group is more than just these three giants. It's an archipelago of over 50 galaxies, most of them dwarf galaxies, small, faint collections of a few billion stars or less. They have names like the Large and Small Magellanic Clouds, visible to the naked eye from the southern hemisphere, or the countless, nearly invisible spheroidal dwarfs. These smaller systems are the building blocks of larger ones. We witness streams of stars being torn from them, assimilated by the gravitational pull of their larger hosts. It is galactic cannibalism, a fundamental process of cosmic evolution, playing out over eons, right here in our own backyard. Now we must pull back our perspective. Our local group, this collection of 50-odd stellar islands, is not isolated. It is merely a tiny outlying suburb of a much grander structure. We accelerate again, and the galaxies of the local group shrink into points of light, forming a small gravitationally bound cluster. Other clusters appear, other families of galaxies, some small, some large. They are not scattered randomly. A pattern begins to emerge. They are all being drawn, like leaves in a cosmic river, towards a single, massive concentration of matter. We are entering the Virgo supercluster. This is our home on a grander scale, a flattened superstructure containing over 100 galaxy groups and clusters. It spans 110 million light-years, and at its heart lies the Virgo cluster, a monstrous collection of over 2,000 galaxies, a true galactic megalopolis. As we approach, the view from our vessel transforms. The sky is no longer mostly black with scattered points of light. It is filled with galaxies, spirals, ellipticals, lenticulars, irregulars. They are everywhere, in every direction. It is a staggering, overwhelming sight. At the very centre of this gravitational storm sits the king, Messier 87, a supergiant elliptical galaxy. It is nothing like our spiral Milky Way. It has no elegant arms, no blue regions of new star birth. It is a monolithic, featureless globe of light, a vast, ancient city of over 1 trillion old yellow and red stars. M87 is what remains after countless galactic mergers. It is a cosmic conqueror, having consumed its neighbours over billions of years. Its gravitational sphere of influence is immense, holding the entire Virgo cluster in its grip. From its core, we witness one of the universe's most extreme phenomena. A relativistic jet of plasma, a focused beam of particles and energy, erupts from the galaxy's central supermassive black hole. This is the black hole famously imaged by the Event Horizon Telescope, a behemoth 6.5 billion times the mass of our Sun. The jet it produces screams out into intergalactic space for 5,000 light-years, travelling at nearly the speed of light. It is a testament to the unimaginable power locked within galactic cores, an energy source that can shape the evolution of the entire cluster. Leaving the chaotic heart of the Virgo cluster, we continue our journey, but a profound mystery guides our path. We feel it, a persistent, inexorable pull. Our entire Virgo supercluster, along with thousands of other galaxies in our cosmic neighbourhood, is moving. We're all hurtling at 2 million kilometers per hour towards a single, unseen point in the direction of the constellation Centaurus. This gravitational anomaly is known as the Great Attractor. For decades, its nature was shrouded in mystery, hidden from view by the dense plain of our own Milky Way, a region called the Zone of Avoidance. Explorer 25P/70 now pierces that dusty veil. We traverse the obscuring clouds of our own galaxy and emerge on the other side, and there we see it, the heart of the Great Attractor region, the Norma Cluster, a rich and massive cluster of galaxies. But even this is not the full story. The Norma Cluster itself is just one part of an even larger structure, the true source of this immense gravitational pull. We push onward, and the grandest picture of our local universe finally reveals itself. Our Virgo supercluster, the Great Attractor, and countless other structures are all connected. They are not separate entities, but provinces within a single, unfathomably vast cosmic continent. Astronomers have named this structure Laniakea, a Hawaiian term meaning immeasurable heaven. It is 520 million light-years across and contains 100,000 galaxies, all flowing towards a common centre. We are a single drop of water in an oceanic current of galaxies, our path defined by the subtle topography of space-time itself, shaped by the mass of this incredible supercluster. This concept of interconnected structures forces us to zoom out even further. Laniakea, as magnificent as it is itself just one node in an even more fundamental architecture. As our vessel travels for hundreds of millions of light-years, the underlying pattern of the universe becomes clear. It is a web, the cosmic web, the largest structure in existence. Matter is not distributed uniformly. It is arranged in colossal filaments, unimaginably long tendrils of dark matter, threaded with galaxies and galaxy clusters. These filaments stretch across the cosmos, connecting at dense nodes which are the superclusters like Laniakea. Between these filaments lie the great cosmic voids, vast, nearly empty expanses of space. To truly comprehend this, imagine the universe as a colossal three-dimensional spider's web. The glistening threads are the filaments, and the galaxies are like tiny dewdrops clinging to them. The junctions where threads meet are the bustling superclusters, and the immense empty spaces between the threads are the voids. Our journey now becomes one of navigating this web. We enter a filament, a river of light stretching for 500 million light-years. From our perspective, it's a celestial highway. Galaxies drift past us in a stately procession, a chain of island universes linked by invisible bridges of dark matter. The gravitational pull of the filament guides our path. We see galaxies in all stages of life along this cosmic thread. We witness elegant spirals, their arms tracing perfect logarithmic curves. We encounter massive ellipticals glowing with the serene light of ancient stars. And we see chaotic, irregular galaxies, beautiful in their asymmetry, often sites of furious starburst activity. We see galaxies interacting, their gravitational fields reaching out to one another across tens of thousands of light-years. Two spirals perform a delicate tidal dance, their arms distorted, pulling streams of stars from one another. This is the cosmic web in action, a dynamic, evolving structure, funneling matter along its pathways, feeding the growth of clusters at its nodes. But the web is not all light and activity. To understand the structure, we must also experience its absence. We steer Explorer 25P/70 off the filament, into the emptiness. We are entering a cosmic void. The change is profound and deeply unsettling. The constant stream of passing galaxies dwindles, then ceases entirely. The sky becomes almost completely black. Here and there, a single, lonely galaxy might be seen, a cosmic castaway. But mostly there is nothing. This is the Bhuta's void, sometimes called the Great Nothing, a nearly spherical region of space some 330 million light-years in diameter, containing only a handful of galaxies where thousands would be expected. The silence here is more than just an absence of sound. It is an absence of matter, an absence of light, an absence of gravity. It is a chilling existential emptiness. If a civilization were to arise on a planet in one of the few galaxies within this void, its astronomers would look out into the night sky and see almost nothing. They might conclude they were entirely alone in the universe, unaware of the brilliant teeming cosmic web that lay just beyond their horizon of perception. Spending time in the void is a crucial part of our journey. It reminds us that the universe's structure is defined as much by its emptiness as by its substance. The voids are the great cosmic deserts that make the filaments and clusters seem like vibrant, life-giving oases. As we continue our voyage, a fundamental principle of cosmology becomes our lived experience. We're not just travelling through space, we're travelling through time. The light from the galaxies we're now approaching has taken billions of years to reach this point. We are looking into the deep past. The galaxies begin to look different. They appear younger, more chaotic. We are entering the era of teenage galaxies. Suddenly we encounter an object of blinding intensity. It outshines its entire host galaxy by a factor of thousands. This is a quasar, a quasi-stellar object. It looks like a star, but it is something far more violent. It is the accretion disk of a supermassive black hole at the centre of a young galaxy, feeding voraciously on surrounding gas and dust. As this material spirals into the black hole, it is heated to trillions of degrees, releasing an amount of energy that defies mundane comprehension. Quasars are the lighthouses of the early universe, beacons visible from across billions of light years, signalling the chaotic adolescence of galactic evolution. Their light is a fossil, a record of a time when the universe was smaller, denser, and far more violent. We fly through galaxies in the throes of cataclysmic mergers. Here we see the antennae galaxies, two formerly normal spirals locked in a gravitational death spiral. Long tendrils of stars and gas have been flung into space, creating the insect-like antennae for which they're named. Where the galaxy's gas clouds have collided and compressed, a firestorm of star formation has been ignited. Millions of brilliant blue supergiant stars are being born, living fast and dying young in spectacular supernova explosions. This is not destruction. It is violent, chaotic creation. From the wreckage of these two galaxies, a single, larger, more massive elliptical galaxy will eventually be born. We are witnessing the primary mechanism of galactic growth in real time. Our journey takes us further and further back, 10 billion years into the past, 12 billion. The universe is noticeably different now. Galaxies are smaller, more irregular, less organised. The grand spirals and giant ellipticals of the modern era have not yet formed. The cosmos is a construction site, filled with the smaller building blocks that will one day assemble into the majestic structures we know. The light here is bluer, dominated by massive hot young stars. These are starburst galaxies, stellar factories working in overdrive, converting their gas reserves into new suns at a ferocious rate. The entire universe is more active, more energetic. Explorer 25P/70 pushes on to the very edge of our vision. 13 billion years ago, 13 and a half, we are approaching the cosmic dawn. Here we find the very first galaxies, as seen by instruments like the James Webb Space Telescope. They are nothing like the galaxies of today. They are small, clumpy, irregular knots of matter, but they are blazing with a fierce, brilliant light. This light comes from the mythical first generation of stars known as Population 3 stars. Forged from the pure hydrogen and helium of the Big Bang, they were hundreds of times more massive than our Sun. They burned incredibly hot and incredibly bright, shining with a pure ultraviolet light, and lived for only a few million years before exploding as the first supernovae. These first stars and their host proto-galaxies were the pioneers. They were the first lights to switch on in the universe after hundreds of millions of years of darkness following the Big Bang, an era known as the Cosmic Dark Ages. Their intense ultraviolet radiation began the process of ionization, stripping electrons from the neutral hydrogen gas that filled the cosmos, making the universe transparent to light for the first time. We are witnessing the moment the universe woke up, the moment the first complex structures ignited and began to shape the cosmos into the web of light we see today. We have reached the limit. 13.8 billion light-years away. Before us lies not a wall, but a curtain, the cosmic microwave background radiation, the afterglow of the Big Bang itself. It is the light from the moment the universe became transparent, stretched and cooled over eons into faint microwaves. This is our ultimate horizon. We can see no further back in time because before this moment, the universe was an opaque, superheated plasma. Our journey through the galaxies is complete. We have travelled from our quiet suburban street in the Milky Way, through the bustling metropolis of Virgo, along the great cosmic highways of the filaments, across the profound emptiness of the voids, and back through time to witness the very first sparks of cosmic dawn. What have we learned from this impossible voyage? We have learned that our universe is not a random scattering of stars, but a structure of breathtaking complexity and order, a web of matter and energy, evolving over billions of years. We have seen that galaxies are not static objects, but living, changing ecosystems of stars, gas, and dust. They are born, they grow, they collide, they merge, and they die. Our own existence is tied to this grand cosmic cycle. The iron in our blood, the calcium in our bones, the oxygen we breathe. All of it was forged in the hearts of stars that lived and died in galaxies long ago. The Explorer 25P/70 turns for home, its memory banks filled with a data set so vast it represents a complete portrait of cosmic history. The journey back is a silent one, a time for reflection. We have flown through trillions of stars across hundreds of thousands of galaxies, and in all this staggering immensity we have found no confirmed sign of another intelligence. The silence of the void echoes with the Fermi paradox. If the universe is so vast, where is everybody? Perhaps life is incredibly rare, a precious accident on a lonely planet. Or perhaps it is we who are young, a nascent consciousness only just opening its eyes to a cosmos teeming with life far beyond our current comprehension. Or maybe the question itself is flawed. Maybe the universe's greatest creation is not life, but structure itself. The elegant spiral of a galaxy, the intricate weave of the cosmic web, the fundamental laws of physics that allow for such complexity to arise from the simplicity of the Big Bang. Perhaps we are not the observers of the universe, but one of the ways the universe observes itself. The atoms within our vessel, the consciousness that designed its mission, are made of stardust. We are a piece of the cosmos, awakened, looking back at our origin. The light of our own sun, Sol, once again becomes a beacon. The pale blue dot of Earth emerges from the blackness. It seems impossibly small, fragile, and beautiful after the gargantuan scales we have witnessed. The mission of Explorer 25P/70 is over. But the human journey has just begun. Every galaxy we witnessed is a potential home, a source of knowledge, a new mystery to solve. We flew through the observable universe, and in doing so, we found that the grandest discoveries were not just in the stars, but in the perspective we gained on our own tiny precious world and our unending, unquenchable thirst to understand it all. The journey is the destination, and it will never truly be over.
It begins with a whisper, not a bang. There is no sound, no explosion, no shudder of the earth. There is only a profound and sudden silence. It's a silence that blooms in the heart of our machines, a ghost that slips into the wires and extinguishes the light within. You feel it first as an inconvenience, a momentary glitch in the flow. The video you were streaming freezes on a face mid-laugh, now a meaningless mosaic of pixels on a dead screen. Your phone, held in your hand as a modern talisman, a gateway to the entire collective consciousness of humanity, becomes a cold, inert slice of glass and metal. The signal bars are gone, the Wi-Fi icon has vanished, there is nothing. You reboot it, a ritual as ingrained as breathing. But this time the familiar logo doesn't lead to a universe of connection. It leads back to blackness. A flicker of annoyance gives way to a prickle of unease. You glance at your laptop, your smart television, your digital assistant. All dark, all silent. A spreading void is creeping into your home, a technological plague. It is as if someone has thrown a master switch, plunging not just a city, but the entire planet into an invisible dark age. This isn't a power cut, not in the way you've ever known. The lights might even still be on for now, a lingering phantom of a world that just moments ago made sense. But the systems that allow those lights to function are already dying. The global financial markets, a frantic dance of algorithms and light-speed trades, have flatlined into a catatonic state. Trillions of dollars in digital wealth, an abstract concept we all agreed to believe in, has evaporated into the ether, its existence no longer verifiable. The intricate ballet of global logistics, the just-in-time delivery of food, medicine, and fuel grinds to a catastrophic halt. Container ships, vast steel behemoths guided by satellites, are now blind, drifting in the currents of the world's oceans. Aircraft, once held aloft by a constant stream of data from the ground, are suddenly flying on instinct and decades-old principles alone, their pilots frantically trying to raise a voice in a sky that no longer listens. The silence deepens, becoming a physical presence. It is the silence of a billion conversations cut short. The silence of a global nervous system that has suffered a fatal stroke. Within hours, the secondary effects begin their cascade. The power grids, deprived of the sensitive computer controls that keep them balanced on the knife edge of supply and demand, start to fail. They collapse not in neat, predictable sections, but in violent, convulsive surges, frying transformers and shattering infrastructure in a way that will take not days or weeks to repair, but years, decades. Now the true darkness begins. Water purification plants cease their pumping. Natural gas pipelines lose pressure. Hospitals, their backup generators finally sputtering out of fuel, fall into a terrifying quiet, the life-sustaining hum of machinery replaced by the shallow breaths of the dying. The world we built, a magnificent, fragile tower of interconnected technology, has crumbled into dust in less time than it takes to watch a movie. We are left in the twilight of our own incredible achievements, stranded on the shores of a new primitive continent. Is this a fever dream, a paranoid fantasy spun from the anxieties of our hyper-digital age? Is it a scene from a blockbuster film designed for our entertainment, a thrilling but ultimately safe exploration of a future that will never be? Or are you watching a dress rehearsal, a meticulously researched preview of a genuine looming reality? The terrifying truth is that this scenario is not just possible, it is, according to a growing chorus of concerned scientists, inevitable. They fear we are sleepwalking towards a precipice oblivious to the celestial threat that gathers its strength 93 million miles away. We look to the sky and see a friend, a gentle, life-giving star, the serene anchor of our solar system. We have forgotten its true nature. Our sun is not a tranquil ball of light. It is a chaotic, unimaginably violent nuclear furnace. Its surface is a roiling ocean of plasma, 1,000,000 degrees hot, racked by magnetic forces that dwarf the power of every nuclear weapon on Earth, combined into a single terrifying instant. This star, our star, is a slumbering dragon, and for the entirety of human history, we have been living through a period of its relatively gentle breathing. But it is starting to stir, and the scientists, who study its every flicker and spasm, have seen something that chills them to the bone. They are tracking the convergence of solar cycles, the alignment of magnetic polarities, and the emergence of sunspot clusters of unprecedented size and complexity. Their models are all pointing to a single, terrifying conclusion: that the sun is gathering its strength for a storm of historic proportions. A superstorm. It is an event that has a precedent. In 1859, before the world was webbed in copper and silicon, a solar storm of colossal magnitude struck our planet. Known as the Carrington event, it was a planetary-scale electromagnetic pulse. The nascent technology of the day, the telegraph system, was its primary victim. Wires spontaneously burst into flames. Operators were electrocuted at their posts. The northern lights, the aurora, were seen as far south as the Caribbean, so bright that people could read a newspaper by their eerie dancing glow at midnight. It was a spectacle, a curiosity, a minor disruption in a world run by steam and muscle. Now imagine the power of a Carrington-class event, or one even stronger, unleashed not on a world of telegraphs, but on our world. A world utterly and completely dependent on the fragile microtransistor. It wouldn't just set our communications back to the 19th century. It would shatter the very bedrock of 21st century civilization. The threat is no longer abstract. It now has a name, a designation whispered in the halls of astrophysics departments and clandestine government agencies. It is a hypothetical classification for a convergence of phenomena that computer simulations predict will reach a terrifying crescendo. They call it 3I, Atlas. The I stands for interplanetary, a storm so vast its shockwave will be felt across the inner solar system. The 3 refers to its predicted kinetic energy, a power classification so far beyond our current scale it had to be invented. And Atlas. Atlas is an acronym, Atmospheric Terrestrial Link, Annihilation Storm. It is a name chosen not for its poetry, but for its brutal accuracy. It is a forecast for the end of our connected world. This is not a prophecy written in an ancient text. It is a stark warning, written in the language of mathematics and physics, emerging from the most sophisticated solar observatories ever created. These sentinels, staring into the heart of our star, are detecting the early tremors. They are mapping the buildup of magnetic energy in the sun's corona, a celestial battery charging to a catastrophic level. The data suggests that sometime in the final quarter of 2025, the sun will unleash a coronal mass ejection, a CME of such biblical scale that it will overwhelm Earth's natural defenses. Our magnetosphere, the planetary shield that has protected life here for eons, will be punched through, torn and battered into submission. What follows will be an invisible tsunami of charged particles, a wave of electromagnetic fury traveling at millions of miles per hour, striking our planet with the force of a cosmic sledgehammer. Its first victim will be our orbital infrastructure. The thousands of satellites that form the backbone of our global village, our eyes and ears in the heavens, will be instantly fried into useless debris. GPS, weather forecasting, global communications, all will cease to exist. But this is only the prelude. As the storm's energy slams into the upper atmosphere, it will induce immense electrical currents in the ground beneath our feet. Our power grids, our vast, continent-spanning networks of wires, will become unwitting antennae absorbing this apocalyptic surge. The intricate web that powers our existence will overload, and in a cascade of failures, it will burn itself out from the inside. This is the scenario that keeps engineers and national security experts awake at night. The so-called Internet apocalypse, a catastrophe that could, in a matter of minutes, render every digital device on Earth a useless relic of a lost civilization. This isn't a story about the end of the world. It is a story about the end of times, a time's world ours, the one we have so carefully, so brilliantly, and perhaps so foolishly constructed. It raises the most fundamental questions we can ask about ourselves. How did we become so powerful, yet remain so vulnerable? We have built a glass house on the slopes of a volcano, mesmerized by the beauty of our own reflection, while ignoring the rumbles from within. The story of 3I, Atlas, is the story of that volcano. It is a journey into the heart of our sun, a place of unimaginable violence and power, to understand the physics of its fury. It is a race against time, following the scientists and engineers who are desperately trying to build a shield before the storm breaks. And it is a stark examination of our own society, a deep dive into the fragile interdependencies that hold our civilization together. Over the next 2 hours, we will peel back the layers of this existential threat. We will travel from the cutting-edge solar observatories that watch the sun's every move to the secretive government bunkers where contingency plans are being drawn. We will meet the brilliant minds who saw this coming and the powerful forces who chose to ignore their warnings. We will explore the science of space weather, a field of study that has morphed from academic curiosity into a matter of planetary survival. Most importantly, we will confront the ultimate question. When the silent storm arrives, as the evidence suggests it will we be ready, or will the legacy of our era be written in the darkness? A cautionary tale of a civilization that reached for the stars, only to be undone by the one it could never escape. The clock is ticking. Late 2025 is not a distant, abstract future. It is right around the corner, and the dragon is waking up. What if the future of our world was decided not in a boardroom or on a battlefield, but in a quiet English garden, more than a century and a half ago? The date is September 1st, 1859. The air is thick with the scent of late summer blooms and the hum of progress. Across the globe, a new invention is shrinking the world, a nervous system of copper wire and clicking relays called the telegraph. It is the pinnacle of human ingenuity, the very definition of modern. In his private observatory near London, a wealthy brewer and amateur astronomer, Richard Carrington, is engaged in his daily ritual. He is meticulously projecting the sun's image onto a screen, sketching the dark, churning blemishes he sees on its face, sunspots. It is painstaking, repetitive work, a study in quiet patience. But on this morning, patience is shattered by impossibility. 2 points of light, blindingly white, suddenly erupt from a cluster of sunspots. They are so intensely brilliant, they defy description, an incandescent fury that seems to burn a hole not just in his projection, but in reality itself. He is stunned, convinced his equipment is faulty, that his eyes are playing tricks, yet the phantoms remain searing themselves into his vision. For 5 minutes, he is the only human being in history to witness such an event, a direct naked view of the sun unleashing a fraction of its true power. He feels a deep, instinctual unease, a sense of having trespassed, of seeing something no mortal was meant to see. He does not know it yet, but he has just become the first witness to the greatest solar storm in recorded history. He has seen the flash. The thunder is on its way. 17 hours later, just before dawn, on the other side of the world, the sky begins to burn. From the snows of the Rocky Mountains to the humid shores of the Caribbean, the heavens are torn asunder by curtains of light. Vivid auroras of crimson, green, and violet pulse and dance with terrifying speed so bright that miners in Colorado are awakened and begin preparing breakfast, mistaking the celestial inferno for the rising sun. In Cuba, sea captains log the appearance of rose-colored fire, while bewildered citizens in Honolulu gaze upwards at a spectacle that should only ever belong to the frozen poles of the Earth. It is a moment of profound planetary awe, a beautiful and terrible vision. But along those slender copper wires of the telegraph network, the beauty gives way to pure chaos. This is not some distant, harmless light show. A phantom energy, an invisible electrical tide, is surging through the Earth itself, and the telegraph lines are acting as immense antennas channeling the storm. In telegraph offices across North America and Europe, the mundane clicking of machinery descends into a nightmare. Sparks leap from the transmission keys, delivering violent electric shocks that throw operators from their chairs. The delicate chemical papers used to record messages burst into flames, igniting fires in offices from Washington, D.C. to Paris. The system, humanity's great triumph over distance, is turning on its creators, and then the strangest thing of all begins to happen. Terrified operators under orders to try and restore communications disconnect their batteries, cutting all power to the lines, and the machines keep working. Messages continue to be sent and received for hours, powered by nothing more than the raw, untamed electricity of the sky. It is as if the planet itself has become a battery, and the aurora borealis is the current flowing through a global circuit. It is a ghost in the machine, a terrifying demonstration of a power we had built our world upon but fundamentally did not understand. The Carrington event, as it would come to be known, was a cosmic warning shot. It was the sun reminding its tiny orbiting children that the light which gives us life can also deliver devastating ruin. In 1859, the consequences were manageable. A few burned offices, a few singed beards, a global network brought to its knees for a day or two. It was a spectacle, a mystery, a scientific curiosity. But it left behind a question that would haunt us for generations, a question that grows more urgent with every passing year. If this is what the sun did to a world of simple iron and wire, what would it do to ours? To answer that, we have to journey into the heart of the storm itself, to understand the physics of the weapon our own star can wield against us. What Richard Carrington witnessed was not just a bright spot, it was a solar flare, a cataclysmic explosion on the sun's surface, and it represents one of the most violent events in our solar system. To grasp its scale, you must first reimagine the sun. It is not the serene, perfect sphere you see in the sky. It is a churning, boiling ball of plasma, a fluid of electrically charged particles 1,000,000 kilometers across, governed by forces of unimaginable complexity. Its most potent force is magnetism. But this is not the gentle, predictable magnetism of a compass needle. The sun's magnetic field is a chaotic, tangled nightmare. Because the sun's equator rotates faster than its poles, the magnetic field lines are constantly being stretched, twisted, and contorted like countless trillions of rubber bands being wound tighter and tighter. They store up phenomenal amounts of energy, creating immense magnetic knots that rise to the surface. These knots are the sunspots Carrington was sketching. They are regions of intense magnetic activity cooler than their surroundings, and they are the loaded barrels of the sun's arsenal. Every so often, the tension becomes too much. The twisted magnetic lines, strained beyond their breaking point, suddenly snap and reconfigure themselves into a simpler, more stable shape. This process, known as magnetic reconnection, is catastrophically violent. The energy it unleashes is almost beyond comprehension. In a matter of minutes, a solar flare can release the power of billions of hydrogen bombs. It is a cosmic short circuit on a planetary scale. The immediate result is a flash of radiation across the entire electromagnetic spectrum. A wave of searing X-rays and ultraviolet light erupts from the sun, traveling outwards at the speed of light. This is the first punch. It arrives at Earth in just over 8 minutes without warning. This blast of radiation superheats our planet's upper atmosphere, the ionosphere, causing it to expand and swell. This is what can disrupt high-frequency radio communications, causing blackouts for pilots and mariners. And it can drag on low-orbiting satellites, shortening their lifespan. But the flare, for all its fury, is only the opening act. It is the blinding muzzle flash from the cannon. The real danger is the cannonball that follows. Sometimes the same magnetic explosion that creates the flare is powerful enough to do something even more dramatic. It can vomit a part of the sun itself out into space. This is a coronal mass ejection, or CME. Imagine a bubble of magnetism, billions of tons of superheated plasma of protons and electrons torn from the sun's atmosphere and hurled outwards. It is a solar tsunami, a ghostly hurricane of charged particles, often wider than 100 Earths, traveling at speeds that can exceed 3 million miles per hour. Unlike the flare's radiation, which arrives in minutes, the CME is a lumbering beast. Its journey across the 93 million miles to Earth can take anywhere from 18 hours to several days. This gives us time. It is a crucial, precious window between the initial flash of the flare and the final crushing impact of the plasma cloud. For the people of 1859, it was a silent, unknowable journey. They saw the beautiful auroras, but had no idea they were the grand finale of a cosmic assault that had begun the day before. They were seeing the aftershocks of a collision, a battle being waged in the invisible realms high above their heads. For our planet is not defenseless. It possesses an ancient and powerful shield, a guardian field that has protected life on its surface for billions of years, the magnetosphere. Generated by the churning molten iron in Earth's core, it is a vast, invisible bubble of magnetic force that surrounds our world. It extends tens of thousands of miles into space, a cosmic bulwark against the constant onslaught of the solar wind, the steady stream of particles that flows from the sun. Under normal conditions, our magnetosphere deflects this solar wind the way a ship's bow wave deflects water, channeling the dangerous particles safely around our planet and down towards the poles where they interact with the atmosphere to create the gentle, predictable auroras our shield holds. But the CME that followed the Carrington flare was not the normal solar wind, it was a battering ram. When this billion-ton cloud of magnetized plasma slammed into Earth's defenses, the collision was apocalyptic. Our planet's magnetosphere was compressed with ferocious violence, crushed down to a fraction of its normal size. The shockwave reverberated through the entire system. But the true danger of a CME lies in its magnetic orientation. If the magnetic field within the plasma cloud happens to be aligned opposite to Earth's own magnetic field, the results are catastrophic. It is the cosmic equivalent of bringing the north pole of one magnet to the south pole of another. They don't just repel, they connect. A process called magnetic reconnection occurs on a planetary scale. Earth's shield is breached. The CME's magnetic field lines effectively unzip the front of our magnetosphere, opening a direct channel for a torrent of energy and particles to pour into our upper atmosphere. This is what happened in 1859. An unimaginable flood of solar energy cascaded down Earth's magnetic field lines, overloading the entire system. The auroras, normally confined to the Arctic and Antarctic circles, were the visible proof of this breach. They were pushed all the way down to the tropics as the shield buckled and the solar storm penetrated deeper than ever before. And as this immense surge of magnetic energy swept across the planet, it induced powerful electrical currents in the ground beneath. The Earth's very crust became electrified. Any long conductive material, like the hundreds of miles of copper telegraph wire strung across the continents, acted as a perfect conductor for this planetary current. The phantom energy that powered the telegraphs and sparked the fires was the energy of the sun itself, channeled by a wounded planet. The operators in 1859 had unwittingly built a system perfectly designed to capture the fury of a once-in-a-century solar storm. They had created a lightning rod for a tempest they couldn't see, a storm that raged not in the clouds but in the fabric of space itself. For over 160 years, the Carrington event has served as our benchmark, our worst-case scenario. It was a glimpse of the sun's true potential, a primal force of nature that could reach across the void of space and humble our proudest technologies. We studied it, we modeled it, we told ourselves we understood the threat. We built a world of exquisite technological sensitivity in its shadow, a global civilization utterly dependent on a delicate web of satellites, power grids, and undersea cables, a system 1,000,000 times more vulnerable than the simple copper wires of 1859. We have been living on borrowed time, gambling that a storm of that magnitude would not return in our lifetime. We told ourselves we knew the rules of the game. The sun is the source of the danger, the agent of chaos. Earth's magnetic shield is our only defense, a simple, terrifying equation of power versus resilience. But what if that equation were about to change? What if the fundamental assumptions we have made about this cosmic threat are incomplete or worse, tragically wrong? The universe is rarely so simple, and it has now sent us a messenger from the outer darkness, a traveler whose arrival is set to introduce a new and terrifying variable into this ancient conflict between star and planet. A variable that could amplify the sun's fury in ways we are only just beginning to comprehend, transforming a known danger into an existential nightmare. The baseline threat has always been there, but now something is coming to stoke the flames. And so the die is cast. A colossal wave of charged particles, a phantom breath from our own star, has been unleashed upon the solar system. It is an invisible, silent tsunami crossing 93 million miles of vacuum at speeds that defy comprehension. But this cosmic artillery shell is not aimed at a planet of rock and ice. Its true target is something far more intricate, something far more fragile. It is aimed squarely at the global nervous system we have built for ourselves, the gossamer-thin web of technology that has become the defining feature of human civilization. We have wrapped our world in a second skin of light and logic, a digital ghost that animates every aspect of modern existence. In our relentless pursuit of connection and efficiency, we have constructed the most complex machine in human history. We just never wrote the instruction manual for what happens when its power source, the very star that gives us life, decides to turn against it. We have, without realizing it, built the perfect target. This vast, interconnected architecture did not arise from a single grand design. It grew organically, explosively, a sprawling digital jungle that colonized the planet in less than a single human lifetime. It began as a whisper, a series of clicks between university laboratories, a curiosity for academics and the military. Then it blossomed. It became a marketplace, a library, a town square. Now, it is the fundamental substrate of our reality. Consider the simple act of buying a cup of coffee. That transaction, a fleeting moment of commerce, is in reality a global ballet. Your card, a piece of plastic containing a universe of data, speaks to a terminal. That terminal sends a query that might bounce from a local server to a regional data hub, then across the continent to a verification center, all before checking with a bank whose ledgers are synchronized across multiple time zones. The approval, a stream of ones and zeros, retraces that journey in reverse. All of this happens in the time it takes for you to say thank you. A miracle of speed and complexity, performed billions of times a day for transactions both trivial and monumental. Every dollar, every euro, every yen is now little more than a phantom, an electrical impulse flitting through silicon pathways. The world's financial markets are not housed in marble halls, but in humming server farms, where algorithms execute trades at the speed of light, moving trillions of dollars around the globe in a ceaseless 24-hour torrent. This river of digital wealth is the lifeblood of our society, funding our governments, paying our salaries, building our cities. Yet, its existence hangs by the most slender of threads. We have taken the tangible reality of gold bars and paper currency and transformed it into an ethereal promise, a shared belief encoded in magnetic memory and transmitted through pulses of light. We have built an empire of pure information, assuming with a breathtaking and perhaps reckless optimism that the infrastructure holding it all together would last forever. It is an assumption that has never truly been tested. This digital scaffolding supports much more than just our economy. It is the framework of our social lives, the repository of our collective memory. Our friendships are maintained through transcontinental data streams. Our histories, both personal and cultural, are stored on servers we will never see in clouds that are anything but vaporous. Our entertainment, our news, our political discourse, all are mediated through this single monolithic system. Even the most fundamental utilities of a modern city are now tethered to this network. Water purification plants are monitored and controlled remotely. Traffic flow is managed by interconnected sensors and adaptive algorithms. The logistics that deliver food to your local store rely on a constant flow of inventory data, shipping manifests and delivery schedules, a chain of information as vital as the chain of transport itself. We have become a species entirely dependent on a machine we barely understand, a planetary-scale utility that has woven itself so deeply into the fabric of our lives that we can no longer distinguish its threads from our own. We have built ourselves a magnificent and glorious glass house, forgetting that we live in a cosmic shooting gallery next to a star that has a history of throwing rocks. The physical reality of this global network is a hidden world of technological marvels and shocking vulnerabilities. Its primary arteries, the great data-carrying vessels of our age, do not soar through the sky but lie in the crushing abyssal dark of the world's oceans. More than 99% of all international data traffic travels through a web of undersea fiber optic cables, a network of over 800,000 miles of glass and steel stretched across the most inhospitable terrain on 25 Team. The planet. These are the true conduits of the modern age. Each cable, no thicker than a garden hose, carries within it strands of pristine glass, each no wider than a human hair. Down these crystalline pathways, lasers flash billions of times per second, encoding our emails, our financial transactions, our conversations, our entire digital lives into a language of pure light. They are laid by specialized ships, unspooled, onto the ocean floor, where they must contend with earthquakes, undersea landslides, and the occasional curious shark. Yet these physical threats are not the greatest danger they face. The true Achilles heel of this submerged nervous system is not the fiber itself, but the equipment that keeps the light alive. Over the vast distances of an ocean basin, even the purest light signal will dim and degrade. To counteract this, the cables are studded with repeaters or amplifiers spaced every 30 to 50 miles along their entire length. These are sophisticated, sensitive electronic devices that act as way stations, catching the fading light pulse, regenerating it to its original strength, and sending it on its way. They are the heartbeats of the network, and they require power. This power is fed down the cable itself, a high-voltage direct current sent from landing stations on either side of the ocean. The cable, with its long copper conductor, essentially becomes an enormous antenna, a colossal wire stretching for thousands of miles across the seafloor. When a powerful coronal mass ejection strikes the Earth, the planet's magnetic field begins to vibrate and shift violently. This dynamic magnetic field, through the fundamental laws of electromagnetism, induces powerful, uncontrolled electrical currents in any long conductor. These geomagnetically induced currents, or GICs, would surge down the power lines of the undersea cables. The repeaters, designed to operate on a precise voltage, would be hit with a massive chaotic surge of raw power, a jolt of electricity far beyond their tolerance. The delicate, intricate circuitry within them would be fried in an instant. Not just one or two, but potentially hundreds of repeaters along a single transoceanic cable could be destroyed simultaneously. And because this is a global phenomenon, cables all over the world, particularly those at higher latitudes where the geomagnetic effects are strongest, would suffer the same fate. The arteries of global communication would not just be severed, they would be cauterized, rendered inert. Repairing them is a monumental task. Specialized ships must be dispatched to the precise location of each and every failed repeater. A grapple must be lowered thousands of feet to retrieve the cable from the ocean floor. The damaged section must be hoisted aboard the faulty repeater, spliced out, and a new one painstakingly integrated. It is a process that, for a single repair, can take weeks. In a scenario where thousands of repeaters have failed at once, there are simply not enough ships, not enough spare parts, and not enough time. The great digital bridges connecting the continents would collapse into silence, a silence that could last not for days or weeks, but for months or even years. While the world below goes dark, a second, equally devastating assault would be taking place in the heavens above. High in the silent vacuum of orbit, circling the Earth in a precise and elegant formation, is a constellation of machines upon which we have built the modern science of location and, more importantly, of time. The Global Positioning System, or GPS, is perhaps the most profound and least appreciated utility of the modern era. We think of it as the friendly voice that guides our cars, but its true role is far more fundamental. GPS is, in essence, a global clock of unimaginable precision. Each of the 31 operational satellites carries multiple atomic clocks synchronized to within a few nanoseconds of one another. By receiving the signals from several of these satellites, a receiver on the ground can calculate its position anywhere on Earth with startling accuracy. But it is this timing signal, this constant, ultra-precise pulse from orbit, that has become the silent, unsung conductor of our technological symphony. That financial transaction for your coffee, its timestamp, which prevents fraud and ensures the integrity of the global banking system, comes from GPS. The seamless handoff of your mobile phone call from one tower to the next. It is synchronized by GPS. The stability of the electrical power grid itself, which requires different power stations to feed into the network in perfect phase with one another, is maintained by GPS timing signals. It is the invisible metronome that keeps the entire rhythm of our interconnected world in lockstep. This celestial clockwork is tragically, exquisitely vulnerable. The satellites exist outside the main protection of the Earth's atmosphere and magnetic field, exposed to the full fury of the Sunday. A CME's wave of high-energy protons would arrive first in as little as 30 minutes after the initial flare. These particles are like microscopic bullets capable of penetrating the satellite's shielding and wreaking havoc on their delicate microelectronics. They can cause phantom commands, corrupt memory, and in a severe event, permanently burn out critical components, turning a billion-dollar piece of technology into a dead piece of space junk. Even for the satellites that survive this initial onslaught, a second danger awaits. As the main body of the CME slams into the magnetosphere, it injects a tremendous amount of energy into the upper atmosphere, the ionosphere. This layer of charged particles, which is normally relatively stable, becomes superheated and turbulent, roiling with irregularities. The crisp, clean radio signals from the GPS satellites must pass through this chaotic tempest to reach the ground. As they do, the signals are scattered, bent, and delayed, a phenomenon known as scintillation. The precise timing information they carry is corrupted, becoming hopelessly unreliable. For a receiver on the ground, the satellites would effectively vanish into a fog of radio noise. Navigation would become impossible. The timing signals that synchronize the world's infrastructure would disappear. The symphony would descend into a cacophony. Cell networks would fail. The stock market's high-frequency trading would halt. The power grid would struggle to maintain stability. We would be cast back into a world where we not only do not know where we are, but we also do not know what time it is. The silent conductor would have left the stage, leaving behind an orchestra of chaos. And then there is the oldest and most critical infrastructure of all, the one upon which everything else without exception is built. The electrical power grid. It is the foundation of the pyramid, the system that powers the servers, the communication networks, the water pumps, the hospitals, the lights in our homes. And it is here in this sprawling network of wires and pylons that a solar superstorm can deliver its most devastating earthbound blow. The same principle that induces currents in undersea cables applies to the vast, continent-spanning transmission lines of the grid. These lines, stretching for hundreds of miles, act as immense antennae, soaking up the energy from the fluctuating magnetic field and generating powerful low-frequency direct currents. These GICs are a poison to the grid's most critical components, the extra-high voltage transformers. These are not the familiar pole-mounted transformers you see in your neighborhood. They are behemoths the size of small houses, weighing hundreds of tons. They are the great heart valves of the electrical system, stepping voltage up for efficient long-distance transmission, and then stepping it down for local distribution. When a transformer designed for alternating current, or AC, is fed a significant dose of DC from a geomagnetic storm, a catastrophic process begins. The direct current saturates the transformer's magnetic core, pushing it into a state it was never designed to handle. It effectively creates a massive magnetic short circuit. The transformer begins to draw enormous reactive power from the grid, placing a huge strain on the entire system. Simultaneously, the magnetic fields leaking from the saturated core induce eddy currents in the transformer's structural supports, its bolts, and its casing. These components begin to heat up rapidly and uncontrollably. The transformer, a device filled with thousands of gallons of insulating oil, starts to cook from the inside out. The oil breaks down, generating flammable gases. The internal windings, normally bathed in this cooling oil, can reach temperatures so high that their copper melts and slumps, creating a permanent fatal short. Within minutes, a machine that took years to build can be reduced to a multi-hundred-ton piece of molten slag. This is not a theoretical risk. During a powerful geomagnetic storm in 1989, the entire power grid of Quebec collapsed in just 90 seconds, plunging 6 million people into darkness. That storm was, by historical standards, a moderate one. A true Carrington-class event would not just cause a regional blackout, it would trigger a continental or even global cascade of transformer failures. And this is the terrifying crux of the problem. These giant transformers are not items you can buy off a shelf. They are custom-built, highly specialized pieces of equipment. Each one is designed and manufactured for its specific place in the grid. The lead time to build a new one, from order to delivery, can be anywhere from 12 to 24 months, and that is during normal times. There is no strategic reserve of these machines. There are very few factories in the world capable of building them. In a scenario where dozens or even hundreds of them are destroyed across a continent simultaneously, the manufacturing capacity to replace them simply does not exist. The lights would go out and they would not come back on for a very, very long time. This, then, is the anatomy of the perfect storm. It is not one single point of failure, but a confluence of interconnected, cascading disasters. It begins with the sun itself producing a CME that is not only powerful but also fast, giving us less time to prepare. Crucially, the storm must be aimed directly at us, a cosmic bullseye, and it must have the right magnetic orientation. If the magnetic field embedded within the CME cloud is aligned to the south, it will efficiently cancel out a portion of the Earth's own northward-pointing magnetic field, opening a gateway for a torrent of energy and plasma to pour into our upper atmosphere. This is the scientific key that unlocks the door to planetary-scale disruption. It creates a storm of unprecedented intensity, one that induces crippling currents in our undersea cables, fries our orbital infrastructure, and brings our electrical grid to its knees. For decades, scientists and engineers studied these risks in isolation. The power engineers worried about transformers. The satellite operators worried about orbital debris and solar protons. The telecommunication experts worried about cable cuts. Each saw a piece of the puzzle. But a frightening new understanding is now dawning within the scientific community, the dawning of the awareness of systemic risk, the realization that these are not separate vulnerabilities, but deeply dangerously intertwined. A failure of the power grid means the internet's server farms go dark. It means the GPS ground stations cease to operate. It means the landing stations for the undersea cables lose power. A failure of GPS means the power grid loses its ability to stay synchronized, making a collapse more likely. A failure of the internet means the logistics to repair any of this infrastructure break down. You cannot order a new transformer if the communication and financial systems are offline. You cannot dispatch repair crews if there is no fuel, because the pumps at the gas station are electric. Every system depends on every other system in a fragile, circular, and entirely untested loop. We have not built a series of independent networks. We have built a single global machine, and we are now beginning to understand that it has a single system-wide off switch, and the sun's finger is hovering right over it. The ghosts of the past, as we have seen, offer us a stark and humbling lesson. They remind us that our star, the giver of life, is also a slumbering giant capable of lashing out with a fury that can scorch civilizations back to a dark age. The Carrington event, the Quebec blackout, these were not anomalies. They were whispers, previews of a power we have only begun to comprehend. But those whispers came from a time of ignorance, a time when humanity was a passive victim, blissfully unaware of the cosmic storm gathering just beyond the horizon. We are no longer in that age of innocence. We are no longer blind. For the first time in the 4.5 billion-year history of our planet, a species has developed the audacity to stare directly back into the sun's fiery gaze. We have surrounded our star with a fleet of sentinels, a celestial network of unblinking eyes that monitor its every breath, every tremor. From the Solar Dynamics Observatory capturing images of such staggering resolution that it reveals the sun not as a placid orb, but as a roiling, tempestuous hellscape, to the Parker Solar Probe, a daring emissary from Earth, actually flying through the sun's corona, tasting the solar wind, and feeling the pulse of its magnetic heart, we have instrumented our star in ways our ancestors could only dream of. These missions are humanity's early warning system, our watchtowers on the cosmic shore. Yet seeing is not the same as understanding, and understanding is not the same as predicting. For decades, the data pouring back from these probes was an overwhelming flood, a chaotic symphony of light and energy that defied easy interpretation. Forecasting a solar storm was more art than science, akin to predicting a single rogue wave in the middle of a planetary ocean. We could see the sunspots, those dark, complex blemishes on the solar surface, and we knew they were the wellsprings of violent eruptions. We could measure the twisting of their magnetic fields, the solar equivalent of a coiled spring, but we never knew with any certainty which one would snap, or when, or how hard. The process was reactive, a constant scramble after the fact. This, however, began to change with the dawn of a new kind of intelligence. Not on a distant world, but right here on Earth. Deep within the climate-controlled sanctums of supercomputing centers, a quiet revolution was taking place. Scientists began to build a digital twin of our sun, a virtual star born from petabytes of observational data and the fundamental laws of physics. This wasn't just a picture. It was a living, breathing simulation, a complex mathematical construct that could model the flow of plasma from the core to the corona, a gravitational gyroscope spinning in the void of cyberspace. They fed this digital entity everything we knew: the 11-year ebb and flow of the solar cycle, the subtle vibrations detected by helioseismology that reveal the secrets of its interior, the intricate dance of magnetic field lines as they emerge, tangle, and violently reconnect. For years, these models grew more and more sophisticated, learning the sun's moods, its rhythms, its violent temperament. They began to move beyond simply explaining what had already happened. They started to whisper about what was yet to come, and in the late 2010 seconds, as the simulations grew ever more powerful, assimilating real-time data from our solar fleet, a new methodology emerged. It was called predictive modeling, but that name feels too sterile, too academic. This was something more. This was a form of digital prophecy grounded not in mysticism but in magnetohydrodynamics. The models began to flag certain magnetic configurations as precursors to extreme events, identifying patterns in the chaos that were invisible to the human eye. They could see the deep-seated instabilities building weeks before a sunspot even became a major threat. It was like listening for the deep, resonant hum of an engine about to fail, hearing the strain in the metal before the catastrophic fracture. Then, as the sun began to awaken from its slumber and climb toward the peak of solar cycle 25, the models started to converge on a singular, terrifying hypothesis. It wasn't a vague warning of increased activity. It was specific. It was quantitative. It had a name. A designation given to a probabilistic forecast of such magnitude. It demanded a unique classification, 3I, Atlas. The name itself is a chilling piece of bureaucratic poetry. Atlas stands for the Advanced Terrestrial Solar Link Analytical System, the network of observatories and supercomputers that collectively serve as the program's brain. It is the system that holds up our shield, trying to warn us of the heavens' wrath. But it's the first part of the designation 3I that truly defines the threat. It stands for Impending Interconnection Impasse. A clinical, almost mundane term for an event that has the potential to sever the very connections that define our modern world. It is the scientific community's carefully chosen code for the internet apocalypse. 3I Atlas is not a comet. It is not an asteroid. It is a prediction, a ghost in the machine. It is the culmination of all our watching and all our learning, a statistical nightmare that has coalesced from the intricate dance of solar physics. The models running millions of future scenarios based on the sun's current trajectory began to flag a period in late 2025 with a disturbingly high probability of a catastrophic event, not just a powerful flare, not just a fast-moving coronal mass ejection, but a perfect storm, a confluence of worst-case scenarios that together would create a solar outburst of almost mythological proportions, an event that would make the Carrington event look like a mere firecracker. So, what is the anatomy of this predicted monster? What makes the 3I Atlas forecast so uniquely terrifying? First, it anticipates not one eruption but a series of them, a cascading failure across the face of the sun in a process known as sympathetic flaring. The models predict the emergence of several colossal magnetically complex sunspot regions, all clustering on the Earth-facing side of the sunday. When the first one erupts, the sheer force of its magnetic realignment will send a shockwave through the sun's corona, destabilizing the others like a chain of celestial dominoes. Instead of a single localized blast, we could be facing a solar hemisphere on fire, erupting with a coordinated planet-drenching fury. From this synchronized cataclysm, the 3I Atlas model predicts the launch of multiple CMEs, vast clouds of magnetized plasma, each containing billions of tons of solar material. But this is where the scenario becomes even more sinister. The initial CMEs, powerful in their own right, will be followed by a subsequent eruption, one that is even faster, even more energetic. This trailing blast will act as a cosmic predator. It will race through the solar system, catching up to and consuming the clouds ahead of it. This is a phenomenon known as a cannibal CME, and the result is a single amalgamated monstrosity of a storm front. It becomes denser, its internal magnetic fields become more tangled and complex, and it carries a kinetic energy that is exponentially greater than its individual parts. It is a solar tsunami, sweeping up everything in its path, growing in power and complexity as it hurtles toward the inner solar system. Yet even this colossal power is not the most dangerous aspect of the 3I Atlas prediction. The true destructive potential of any solar storm lies in a specific crucial detail: its magnetic orientation. Think of Earth's magnetosphere, our planetary shield, as a locked door. Most CMEs arrive with their magnetic field oriented in a way that doesn't fit the lock. They batter the shield, causing beautiful auroras and minor disruptions, but they cannot get in. The magnetosphere, for the most part, holds. The key to unlocking that door is a southward-pointing magnetic field within the CME, what scientists call a negative BZ. If a CME arrives with a strong, sustained, southward-pointing magnetic field, it is the perfect key. It will connect with Earth's northward-pointing magnetic field at the front of the shield, initiating a process called magnetic reconnection on an apocalyptic scale. It effectively short-circuits our planet's defenses, opening a vast funnel through which torrents of solar energy and radiation can pour directly into the upper atmosphere. The 3I Atlas model predicts exactly this. The complex, tangled fields of the cannibal CME are forecast to arrive at Earth with a brutally strong and terrifyingly stable southward orientation. It will not just knock on the door of our magnetosphere, it will blow it clean off its hinges. The energy transfer from the solar wind into our planet's system would be unprecedented in recorded history. The Carrington event was a direct hit from a powerful magnetically aligned storm. 3I Atlas is predicted to be a Carrington-class event amplified by sympathetic eruptions and a cannibalistic merger, creating a storm so potent, so perfectly geo-effective that our historical analogues fail to capture the scale of the impending devastation. The scientific basis for this prediction is not a fringe theory. It is the result of the same peer-reviewed science that allows us to land rovers on Mars and predict the orbits of asteroids. The WSA-Enlil model, a sophisticated forecasting tool used by NOAA's Space Weather Prediction Center, is one of the primary engines behind this forecast. It combines observations of the Sun's surface with a complex model of the solar wind to simulate the journey of a CME from the Sun to the Earth. When fed the precursor conditions that the Atlas system identifies for late 2025, the Enlil spiral paints a terrifying picture. A dense, high-velocity wave of plasma washing over Earth, its arrival timed with a prolonged and despicably, intensely negative magnetic field. The consequences of such an impact are almost unthinkable, because our world is now fundamentally different from the world of 1859. The Carrington event struck a planet of steam and iron. Its primary effect was on the nascent telegraph network, a simple system of wires on wooden poles. 3I, Atlas, would strike a planet of silicon and light, a world built upon a fragile, interconnected web of microelectronics. Our civilization is a delicate house of cards, built on the assumption of a calm Sunday. 3I, Atlas, is the gust of wind that can bring it all down. The first casualties would be in orbit. Our constellation of thousands of satellites, the backbone of our global communication, navigation, and financial systems, would be flying directly through the heart of the storm. The intense bombardment of high-energy particles would fry their sensitive electronics. The energized upper atmosphere would swell, becoming denser dramatically, increasing the drag on satellites in low Earth orbit. Their orbits would rapidly decay, causing hundreds, perhaps thousands of them to burn up or make uncontrolled re-entries into the atmosphere. GPS would vanish. Satellite television would cease. Global financial transactions which rely on GPS for timing would grind to a halt. The eyes and ears we have in the sky would be blinded and deafened in a matter of hours. Down on the surface, the true catastrophe would begin to unfold. The violent rattling of Earth's magnetic field would induce immense electrical currents not in the atmosphere but in the ground beneath our feet. These geomagnetically induced currents, or GICs, would seek the path of least resistance, surging into the conductive metal of our long-distance power lines. Our electrical grids are not designed to handle this kind of low-frequency DC current. It would flow into the giant transformers at substations, the critical nodes that keep our entire power system functioning. The transformers' magnetic cores would become saturated, causing them to overheat with terrifying speed. Their copper windings would begin to melt, their insulation would fail, and across the globe they would begin to explode. Not just a few, but hundreds, perhaps thousands. This is the true horror of 3I, Atlas. It's not about a temporary blackout. The destruction of these extra high-voltage transformers represents a civilizational choke point. These are bespoke, monstrously large pieces of equipment, weighing hundreds of tons. They take years to build and transport, and we have very few spares. Losing a significant portion of the world's transformer fleet is not a problem you fix in a week or a month or even a year. We are talking about a potential worldwide blackout lasting for multiple years, in some regions possibly a decade. A world without power is a world without clean water, without sanitation, without modern medicine, without refrigerated food, without communication, without law and order. It is a regression of a century or more in the span of a single day. The prediction is on the table, a product of our most advanced science. It is not an absolute certainty. It remains a probabilistic forecast, but the probability is high enough that ignoring it would be an act of collective insanity. For the first time in our history, we may have a credible, specific warning of a naturally occurring civilization-ending event. We have been shown the loaded gun. We have been told when the trigger might be pulled. The question that now hangs in the silent darkness of space A question that will haunt our every waking moment as we approach late 2025 is a simple one. Now that we can see it coming, what in the world are we going to do about it? And so, after its long, silent journey across the void, the wave arrives. It is not a thing of sound or fury, not a spectacle of light that can be witnessed from a window. It is an invisible tsunami of charged particles, a phantom surge of magnetic force, striking Earth's protective shield, not with a bang, but with a deep planetary hum. The aurora, that celestial whisper of the poles, would ignite in a terrifying global scream, a riot of impossible colors painting the skies even at the equator. A beautiful, silent and lethal prelude to the great unwinding. For in that moment, our technological civilization, the intricate web of light and data we have woven around the globe over the last century, suffers a planetary stroke. The first and most critical domino to fall is the one that powers all others, the electrical grid. You must understand, the grid is not merely a network of wires. It is the copper circulatory system of the modern world, and the plasma from 3I Atlas is a universal poison injected directly into its veins. The incoming magnetic field induces massive, uncontrolled surges of direct current into the alternating current system, what engineers call geomagnetically induced currents, or GICs. To the grid, this is like pouring molasses into the delicate gears of a Swiss watch. The high-voltage transformers, the hulking house-sized behemoths that serve as the load-bearing columns of our entire electrical infrastructure, begin to groan under the strain. They are designed to handle immense power, but not this kind. Not this relentless alien surge. Inside their steel casings, their copper windings begin to saturate, to overheat at a catastrophic rate. The insulating oil that cools them boils away, its chemical structure breaking down. The hum from the substations, a familiar background noise of urban life, would rise in pitch to a desperate metallic shriek. And then, one by one, or in devastating regional cascades, they fail. They do not simply switch off. They die violently. An explosion of superheated oil and shrapnel, a plume of toxic black smoke, marking the grave of a city's power. This would not be a localized blackout, a temporary inconvenience remedied in hours. Simulations run by the world's leading energy commissions paint a picture of continental-scale collapse. Hundreds of these extra high-voltage transformers, the irreplaceable linchpins of the entire system, would be pushed past their breaking point, their intricate internal structures fused into useless slag. Here lies the cold, hard logistical nightmare from which there is no quick recovery. An EHV transformer is not an off-the-shelf item. Each one is a bespoke piece of industrial art, weighing hundreds of tons, requiring specialized rail cars to move, and taking 18 months to 2 years to build. We do not have vast warehouses filled with spares. The global manufacturing capacity for these giants is profoundly limited. To replace even a dozen would be a monumental effort. To replace hundreds would be the work of a decade spent in the dark. The initial 72 hours would be a descent from confusion into primal fear. First, the lights flicker and die, plunging homes, streets, and entire cities into a darkness unseen for generations. Backup generators at hospitals and emergency centers kick in their diesel engines, a temporary reprieve, a ticking clock measuring their dwindling fuel reserves. But the fundamentals of modern life would have already vanished. Water pumps would cease to function, silencing the flow to millions of homes. Heating and cooling systems would go inert, leaving populations vulnerable to the elements. The world you know, the world of effortless convenience, would be gone. It would evaporate in a single silent instant, leaving behind a bewildered humanity blinking in the unfamiliar gloom, unaware that this is not an interruption but a new, long-lasting reality. With the grid shattered, the second domino, our global nervous system collapses almost simultaneously. The internet, the very namesake of this apocalypse, would be the first casualty. Submarine cables, the glass threads that weave the continents together into a single conversation, are powered by stations on land. As those stations lose power, the data flows cease. The web of light connecting humanity would be severed. But the damage would be far more profound. Low Earth orbit, the bustling superhighway of our communication and navigation satellites would become a shooting gallery. The same charged particles that cripple the grid would slam into the delicate microelectronics of these orbital assets. Solar panels would degrade, onboard computers would short-circuit, and their finely tuned gyroscopes would be sent into an unrecoverable spin. The global positioning system, the silent, unsung hero of the modern age, the system that governs everything from your phone's map to the timing of global financial transactions, would be among the first to be blinded. The effect would be a great silence, a sudden and total sensory deprivation for our interconnected species. Imagine your phone, your tablet, your computer becoming nothing more than a useless slab of glass and plastic. No calls, no texts, no news from across town, let alone across the ocean. The relentless flood of information that defines our era would be reduced to a single terrifying word: nothing. The world would shrink instantly, its boundaries defined by how far you could walk or shout. Families would be separated with no way of knowing if loved ones just a state away are safe. Governments would lose command and control, their ability to coordinate a response crippled at the very moment it is most needed. The cloud, that abstract realm where we store our collective knowledge, our economies, our memories, would dissipate into a meaningless concept. Data centers, the vast digital libraries of Alexandria of our time, would fall silent as their backup power fails, their stored information locked away in an electronic tomb. We would be cast adrift on a sea of ignorance, haunted by the ghost of a connected world, with rumor and fear becoming the only forms of broadcast. For a society that has forgotten how to function without instantaneous information, this silence would be more terrifying than the darkness itself. It would be the death of certainty, the end of the shared reality that binds us. This communications blackout, coupled with the power grid's demise, triggers the third and perhaps most lethal cascading failure, the complete and utter breakdown of global supply chains. Our civilization is a marvel of just-in-time logistics. The food on your table, the medicine in your cabinet, the fuel in your car, none of it is stored in vast local reserves. It is in constant motion, a river of goods flowing ceaselessly across oceans and continents, managed by algorithms that depend on power and connectivity. In the world after 3i, Atlas, that river runs dry overnight. Think of a supermarket. Without power, the registers are dead, the lights are out. The refrigerated and frozen sections begin to thaw, a race against time and decay. Within 48 hours, panic buying would strip the shelves of anything non-perishable. Within a week, the stores would be empty husks and there would be no resupply. The trucks that carry the food are stranded, their drivers unable to get fuel because the electric pumps at filling stations no longer work. Their GPS is dead, their dispatchers unreachable. The ports, the great arteries of global trade, would seize up. Container ships 100 miles offshore would become floating prisons, unable to navigate safely or communicate with land. Cranes that lift millions of tons of goods each day would stand idle, their electric hearts silent. The entire physical economy, the movement of real things, would grind to a halt. This is where the true fragility of our existence is laid bare. The consequences are not abstract. They are measured in empty stomachs and desperate thirst. Modern agriculture is an energy-intensive industry. Automated irrigation systems that water the fields would fail, leaving crops to wither under the sun. Processing plants that turn harvests into food would shut down. The cold chain, the unbroken line of refrigeration that keeps food and medicine safe from farm to consumer, would be shattered. Mountains of food would rot in silos and warehouses, while just a few hundred miles away cities would begin to starve. And then there is water. We turn a tap and it appears clean and safe. It is a miracle we have long taken for granted. But this miracle is powered by electricity. Massive pumps draw water from rivers and aquifers, pushing it through a labyrinth of pipes to our homes. Treatment plants use complex, energy-hungry processes to make it potable. Without power, the pumps stop. The purification process ends. Whatever water remains in the reservoirs is all there is, and it will quickly become contaminated. Cities would face a choice between dehydration and disease. This is the point where the veneer of modern society begins to crack under an unbearable strain, revealing the primitive vulnerabilities beneath. The challenges would become medieval in their simplicity: find water, find food, stay warm, stay safe. The complex problems of the 21st century would be replaced by the brutal, stark necessities of survival. Every system we built to insulate ourselves from nature would have failed, leaving us exposed and unprepared. The final domino is society itself. When the pillars of power, communication, and sustenance crumble, the structures of law, order, and economy are not far behind. The financial system as we know it would cease to exist in a matter of hours. The global markets are not physical places. They are a torrent of data, a collective abstraction running on servers that would now be dark. Your bank balance, your mortgage, your stocks, your retirement fund, all of it would become a string of inaccessible code. ATMs would be inert monuments to a bygone age of easy cash. Credit cards would be useless plastic. The world's wealth, so intricately tied to the digital realm, would be trapped, its value plummeting to zero as the system that gave it meaning collapses. Without a functioning currency, commerce would revert to barter, a desperate and inefficient trade of physical goods. This economic implosion would catalyze a social one. As resources dwindle, as hunger and thirst become daily realities, the social contract begins to fray. How do you maintain order in a city of millions when there is no communication, no light, no running water, and dwindling food? Emergency services would be overwhelmed, their own personnel struggling with the same crises as the populace. Hospitals, the last bastions of hope, would become scenes of unimaginable tragedy. Life support systems would fail. Sterile environments would become contaminated. Doctors would be forced to practice a desperate form of battlefield medicine without electricity, without access to records, and with a rapidly expiring supply of modern pharmaceuticals. The intricate division of labor that defines our society, where one person grows the food, another treats the sick, another maintains the power lines, would shatter. Everyone would become a generalist in the art of survival. The trust that binds communities together would be tested to its breaking point and beyond. What the simulations and expert analyses reveal is not a single disaster, but a synchronized systemic failure of everything at once. It's a fire, a flood, a famine, a blackout, and a plague happening simultaneously everywhere. We have constructed a magnificent, glittering tower of technological achievement, but we have built it on a foundation of startlingly fragile glass. We have forgotten the skills of our ancestors, trading resilience for convenience, robustness for efficiency. The chilling reality of a 3I, Atlas-level event is not just the loss of the internet. It is the loss of the last 200 years of progress in the span of a few days. It is a forced reset to a darker, harder, and more brutal age, a world plunged into a long twilight, with no guarantee that we would ever possess the means to find the dawn again. The question then becomes not just how we would survive, but what of our humanity would be left when the lights for the first time in a century go out for good. And so we are left on that precipice, staring into the silent, static-filled abyss of a world disconnected. A world where the intricate web of light and logic that binds us together has been torn asunder by a phantom from deep space. The images we conjured in the preceding moments of darkness, of silence, of a sudden and catastrophic return to a forgotten age are not fantasy. They represent a genuine, calculated risk, a potential future etched into the cold mathematics of astrophysics and electrical engineering. But to leave the story there, suspended in that moment of ultimate dread, is to tell only half the tale. It is to ignore the single most powerful force in this entire cosmic equation, human ingenuity. Because we are not a species that simply waits for the storm to break. We build storm walls. We chart the winds. We listen to the thunder from 1 billion miles away. For every terrifying vulnerability that 3I, Atlas threatens to exploit, there is a shield being forged, a plan being drafted, a global immune response kicking into gear. This is the other side of the story, not the story of our fragility, but the chronicle of our resilience. It begins not on Earth, but a million miles out in the silent gravitational oasis known as Lagrange Point 1. Here, in this exquisitely stable gravitational pocket between the Earth and the Sun, we have placed our sentinels. They are humanity's tripwire, our unblinking eyes, staring directly into the face of our star, waiting for the first sign of its fury. This is the domain of the Deep Space Climate Observatory, or DSCBRVAR, a joint mission between NOAA and NASA. For years it has hung in the void, a silent guardian whose sole purpose is to taste the solar wind long before it ever reaches our planet. Its instruments are not designed to capture beautiful images for public consumption. They are cold, analytical tools. A Faraday cup to measure the speed, density, and temperature of the oncoming plasma. A magnetometer to feel the subtle contortions in the interplanetary magnetic field, the invisible tendrils that will guide the storm. When 3I, Atlas, finally makes its fateful pass, and the Sun responds with that predicted cataclysmic eruption, DSC Viva will be the first to know. It will be engulfed by the wave of charged particles, its sensors screaming a silent digital alarm across the void. That signal, traveling at the speed of light, will outrace the CME itself, which travels at a mere fraction of that velocity. The time difference between that first warning and the storm's arrival at Earth is our most precious commodity. It could be as little as 15 minutes or as much as an hour, a fleeting, terrifyingly brief window, but in that window a world of preparation can unfold. Yet DSC-UVR is not alone in its vigil. It is part of a sophisticated, multi-layered celestial network, an orchestra of observation. Orbiting alongside it is the Advanced Composition Explorer, or ACE, a seasoned veteran of space weather prediction. For over 2 decades, ACE has been sampling the Sun's outflow, creating an unparalleled library of solar behavior. Its data allows forecasters to refine their models, to understand not just that a storm is coming, but its specific character, its magnetic orientation, its density, its internal structure. This detail is everything. A CME with a northward-pointing magnetic field might deliver a glancing blow to our magnetosphere, a spectacular but largely harmless light show. But one with a southward orientation, the kind scientists fear 3I, Atlas will provoke, is the planetary equivalent of a key fitting a lock. It is perfectly aligned to pry open our magnetic shield and pour trillions of tons of energetic particles directly into our upper atmosphere. ACE gives us the intelligence to know which kind of enemy is at our gates. Further back, a silent titan, the Solar and Heliospheric Observatory, or SOHO, watches the Sun's surface itself. A joint project of ESA and NASA. SOHO does not wait for the storm to arrive. It watches it being born. Its coronagraphs, ingenious instruments that create a permanent artificial eclipse, block out the Sun's blinding glare. This allows it to see the ethereal, ghostly tendrils of the corona, the Sun's outer atmosphere where these eruptions take shape. Long before DSC-OVR feels the blast, SOHO will see it. It will capture the image of a billion-ton cloud of plasma leaping from the solar surface, a monstrous celestial beast taking flight. This visual confirmation is the starting gun in the race against time. The moment SOHO's images hit the screens at NOAA's Space Weather Prediction Center in Boulder, Colorado, and at ESA's counterpart in Darmstadt, Germany, the clock truly starts ticking. A global network of scientists, engineers, and grid operators will spring into action, armed with the knowledge of what is coming. And soon a new guardian will join them, the European Space Agency's Vigil mission slated for launch right at this critical juncture. Positioned at Lagrange Point 5, it will view the Sun from the side-tracking solar storms as they barrel through space. This unique vantage point will give us unprecedented insight into a CME's trajectory and evolution, turning our predictions from educated guesses into high-fidelity forecasts. This is not a passive observation. It is an active planetary-scale defense system, a symphony of data flowing from the void to the Earth, all designed to buy us one thing: time. With that precious gift of time, the focus shifts from the celestial to the terrestrial. It shifts to the vast, sprawling, and shockingly vulnerable nervous system of our modern world, the electrical grid. The primary threat here is an invisible enemy, a phantom current born from the interaction between the solar storm and the Earth's own magnetic field. Geomagnetically induced currents, or GICs, they are the silent assassins of our electrical infrastructure. As the magnetosphere flexes and contorts under the solar onslaught, it generates powerful, low-frequency electrical fields on the ground. Long transmission lines stretching for hundreds of miles act like massive antennae picking up these rogue fields. The result is a surge of direct current DC electricity flowing into a system designed exclusively for alternating current, or AC. This is like pouring syrup into the delicate mechanics of a Swiss watch. The DC current floods the massive transformers at the heart of our substations, the critical nodes that step voltage up or down for transmission. It pushes the transformer's magnetic core into saturation, causing it to overheat violently. Internal temperatures can skyrocket in minutes, warping windings, degrading insulation, and literally melting tons of solid copper. The result is catastrophic failure, not a simple blackout, but the physical destruction of a multi-million-dollar piece of equipment the size of a house, an asset that takes months, sometimes years, to build and replace. Losing hundreds of these simultaneously would not be a blackout. It would be a grid collapse from which recovery could take a decade. Facing this existential threat, engineers have been engaged in a quiet, desperate race to fortify these steel hearts of our civilization. The solution is an elegant piece of electrical engineering known as a GIC blocker, or a series capacitor. Installed in the connection between the transformer and the ground, it acts as a kind of sophisticated one-way gate. It allows the normal high-frequency alternating current of the grid to pass through unimpeded, but it presents a formidable wall to the slow-moving, low-frequency direct current of a GIC. It is, in essence, an electrical filter, a safety valve, that can divert the poisonous phantom current safely into the Earth before it can reach the transformer's vulnerable core. The technology is proven. The challenge is one of sheer scale and cost. Retrofitting thousands of high-voltage transformers across a continent is a monumental undertaking. It requires taking critical parts of the grid offline, transporting massive equipment, and performing complex installations. But in the years since the 3I Atlas threat became clear, a quiet, unheralded revolution has been underway. Power companies, spurred by government mandates and the chillingly clear scientific consensus, have accelerated these upgrades. From the plains of North America to the industrial heartlands of Europe and the burgeoning cities of Asia, teams of engineers are working against the clock. They are hardening the grid one substation at a time, installing these crucial defenses in a global effort to prevent the lights from going out for good. Alongside these physical upgrades, new operational protocols are being put into place. When the warning from our space-based sentinels arrives, grid operators will have minutes to act. They can preemptively reduce the load on the most vulnerable transformers, reroute power across less susceptible lines, and in the most extreme cases, initiate controlled sectional blackouts. It is a terrifying trade-off to intentionally plunge a city into darkness for a few hours in order to save it from a darkness that could last for years. But even a hardened power grid cannot save the most intricate and perhaps most vital network of all. The very fabric of the 21st century is woven from threads of glass lying on the floors of our oceans. The submarine fiber optic cables that carry over 99% of all international data are the true circulatory system of our globalized world. Every email, every financial transaction, every video call, every piece of data flowing between continents travels through these undersea conduits at the speed of light. The glass fibers themselves, carrying photons of light, are immune to the electromagnetic fury of a solar storm. But the cables are not simply passive strands of glass. To push a signal across an ocean, the light must be amplified every 40 to 60 miles. This task falls to a series of devices spliced into the cable, known as repeaters or amplifiers. These are the Achilles heel of the Internet. Each repeater is a sophisticated piece of electronics, powered by a high-voltage electrical conductor that runs the entire length of the cable from one shore to the other. These continent-spanning copper wires are in effect the longest electrical conductors on the planet. They are therefore exquisitely sensitive to the very same geomagnetically induced currents that threaten the power grid. A powerful CME would induce a massive, uncontrolled voltage spike along these conductors flowing from the Earth through the grounding stations on either coast. This surge would be more than enough to fry the delicate electronics within hundreds of repeaters simultaneously. An entire transoceanic cable representing terabits of data capacity could be rendered inert in a single instant. The loss of one or two cables can be managed. Data can be rerouted. But the simultaneous loss of dozens of cables across the Atlantic and Pacific would shatter the global internet. Continents would be cut off from one another. The flow of data would not slow down, it would stop. The financial markets would freeze. The logistics that power global trade would collapse. The world's digital heartbeat would fall silent. The challenge of protecting this submarine infrastructure is immense. You cannot simply send a crew to the bottom of the Mariana Trench to install a blocker. The solutions must be more innovative, built into the very design of the system itself. Newer cable systems are being laid with hardened repeaters, featuring enhanced power surge protection and more resilient internal components. But the immense legacy network of older, more vulnerable cables remains the primary concern. Here, the mitigation strategy is one of intelligent dynamic defense. Cable operators working with space weather agencies have developed sophisticated models to predict which specific cable routes will be most affected. The induction effect is not uniform across the globe. It is strongest at higher latitudes and varies based on the geology of the seafloor. With the early warning from space, operators can identify the highest risk cables. They can then implement a radical defensive maneuver, a controlled shutdown. By temporarily isolating the power conductor from its shore-based ground connection just before the storm hits, they can prevent the destructive induced current from ever forming. The cable goes dark, but its hardware is saved. Moments after the storm passes, it can be re-energized, bringing the connection back to life. Simultaneously, a global automated traffic shaping system will engage in a frantic, high-stakes ballet of data. Artificial intelligence algorithms fed with real-time space weather data will begin rerouting global information flows away from the most vulnerable pathways. Trans-Pacific data might be shifted to shorter, less exposed transatlantic routes, or even through terrestrial networks across Asia and Europe. The goal is to move as much critical data as possible onto the most resilient paths before the vulnerable ones are taken offline. It is a race against the clock on a planetary scale, a testament to the complex self-healing capabilities we are building into our global brain. We are teaching our network how to duck, how to brace for impact, how to survive the storm. Yet even with all these shields in place, we must plan for the possibility of failure. What if the storm is stronger than predicted? What if a critical defense fails? Prudence demands that we build lifeboats. If the great ship of the global internet is breached, we need smaller, more resilient systems to carry the essential functions of society. This has spurred a renaissance in decentralized and alternative communication technologies. Engineers are rapidly deploying and testing mesh networks, where devices connect directly to each other rather than through a central tower or server. In a disaster scenario, your phone could become a node in a vast ad hoc network, relaying messages for miles by hopping from one device to the next. This creates a resilient, self-organizing communication web that does not depend on a fragile, centralized infrastructure. Organizations are developing low-bandwidth, satellite-based backup systems designed to transmit only the most critical data, emergency broadcasts, financial settlements, government directives. These are not meant for streaming video, but for keeping the core functions of civilization running. Even older technologies are being given a new lease on life. Amateur radio operators, long seen as hobbyists from a bygone era, are now being integrated into national emergency plans. Their ability to communicate across continents using shortwave radio bouncing signals off the very ionosphere that a solar storm disrupts provides a robust, last-ditch communication channel that is almost impossible to sever completely. These are not replacements for the internet we have lost. They are the digital seeds from which a new connection can grow. They are the emergency services, the government channels, the community networks that will allow us to coordinate, to respond, and to rebuild. They are the assurance that even if the world goes quiet, we will not be left in total silence. From the silent watch at Lagrange Point 1 to the engineers working in the deep hum of a substation, from the AI algorithms rerouting global data to the hobbyist tuning a shortwave radio in their basement, a new picture emerges. It is a picture of a civilization that has looked its own vulnerability squarely in the eye and refused to blink. This is an unprecedented mobilization of science, engineering, and international cooperation, all focused on a single invisible threat from a star 93 million miles away. The shields are being raised, the protocols are being written, the lifeboats are being launched. We are preparing not for the end of the world, but for the storm of a lifetime. And yet, for all our technology, for all our brilliant preparations, a profound and unsettling uncertainty remains. A plan on paper is one thing. The chaos of a global crisis in its final frantic hours is another entirely. The technology can only provide a warning. The truly critical decisions will still fall to human hands. When that final signal arrives, when the clock shows we have mere minutes left, the ultimate test will not be of our circuits or our software. It will be a test of our nerve, our trust, and our collective will to act. And so we arrive at the final, unavoidable truth. Our long journey together, which began in the flickering gaslight of 1859, with a lone astronomer's hand-drawn sketches of an impossible solar flare, has brought us to this precipice of the 21st century. We have traveled from a past of scientific curiosity, where the sun's fury was a spectacle that made telegraph machines spit fire, to a present defined by a profound and terrifying codependence. The ghost of that 19th century storm, the Carrington event, is no longer a historical footnote. It has become the foundational blueprint for a potential global catastrophe, a warning scrawled in magnetic ink across the annals of time. We have seen how that singular event, once an isolated marvel, was merely the first whisper of a conversation our star has been having with us for the entirety of our existence. We have followed the tangled threads of causality, from the sun's churning plasma heart, a thermonuclear furnace, forging the very light and heat that gives us life, to the delicate continent-spanning nervous system of our digital civilization. We traced the path of a transient visitor, the comet 3I Atlas, recognizing how its passage served not as the agent of our doom, but as a cosmic catalyst, a gravitational signpost that compelled us once again to lift our gaze from our screens and look to the heavens. It was a stark reminder that we live within a dynamic, violent system where threats can emerge not just from the cold, distant dark, but from the brilliant, life-giving heart of our own solar system. The comet was a distraction that ironically refocused our attention on the one object in the sky we so often take for granted, the true and ever-present source of both our vitality and our vulnerability. Through this exploration, we have been forced to confront a chilling paradox. The magnificent technological tapestry we have so carefully woven, the very thing that connects us, empowers us, and defines our modern age, is also our Achilles' heel. Every submarine fiber optic cable snaking across the ocean floor, a conduit for the world's knowledge and commerce, becomes a potential antenna for a geoelectrically induced current ready to be fried from within. Every satellite in our orbital constellations, a miracle of communication and navigation, is a fragile sentinel floating directly in the line of fire, its sensitive electronics vulnerable to a blitz of high-energy solar protons. Our power grids, the circulatory system of our society, are vast interconnected metal networks susceptible to a catastrophic surge that could plunge billions into a sudden, protracted darkness. This is the central thesis we must now carry forward from this examination. The so-called Internet apocalypse is not a work of science fiction. It is a clear and present danger grounded in the unchangeable laws of physics and the self-inflicted realities of our technological design. The threat is real, its potential consequences devastatingly severe. Yet, and this is the most critical revelation of our entire journey, this dark future is not an inevitable fate. It is not a destiny written for us in the solar winds. We are not helpless observers awaiting a cosmic judgment. The story of humanity has always been one of confronting the raw, untamed power of nature, from the first fire we learned to control, to the dams we built to tame raging rivers, to the breakwaters we constructed to hold back the fury of the sea. The challenge posed by our own sun is simply the next great chapter in that epic saga, a test of our foresight, our ingenuity, and most importantly, our unity. The knowledge of the coming storm is not a curse, it is a gift. It is the ultimate head start, a period of grace granted to us by the cosmos itself, and how we choose to use this precious fleeting time will define the century to come. What we do now, in the relative quiet between the great solar tempests, determines whether our digital age becomes a footnote in history or the foundation for a resilient, star-faring future. The path forward, the blueprint for our survival and prosperity, rests upon a tripod of concerted, unwavering global action. The first leg of this crucial structure is unprecedented international cooperation. The sun, in its awesome power, recognizes no borders, no ideologies, no political disputes. A coronal mass ejection launched towards Earth is a planetary event, an indiscriminate wave of energy that will wash over every nation in its path. Our response, therefore, must be equally global and indiscriminate in its solidarity. This means the free, open, and instantaneous sharing of all space weather data from every observatory on the ground and every satellite in the sky. It demands the creation and maintenance of a unified global warning system, a network where an observation from the European Space Agency can immediately inform grid operators in North America and Asia, giving them those precious critical Ws of 1000 W, hours, or even just minutes, to execute protective shutdown procedures. We must build a world where the science of heliophysics transcends nationalism, where researchers in Beijing, Boston, and Berlin work not as competitors, but as a single coordinated team of planetary guardians. The very interconnectedness that makes us vulnerable must become the source of our collective strength, turning our global village into a global fortress. The second leg of this vital tripod is a massive and crucially sustained investment in the science of space weather prediction. We have come so far from Carrington's simple drawings, now possessing spacecraft that can look directly into the sun's boiling atmosphere, and AI models that can simulate the complex dance of its magnetic fields. But our understanding remains incomplete. Our forecasts are still probabilistic, not certain. We must move beyond this state of educated guesswork. This requires funding the next generation of solar observatories, placing new cosmic sentinels at the L1 and L5, Lagrange points, positions in space that grant us a stereoscopic 360-degree view of the sun's entire surface. With such a comprehensive perspective, the blind spots from which sunspots can rotate into view and erupt without warning would be eliminated forever. We must pour resources into developing the sophisticated artificial intelligence capable of sifting through petabytes of solar data in real-time learning to recognize the subtle precursors to a catastrophic eruption with a speed and accuracy that no human team could ever hope to match. This is not an esoteric scientific pursuit for a select few. It is as fundamental to our 21st century security as meteorology is for hurricane prediction, or seismology is for earthquake preparedness. We must empower our scientists, giving them the tools they need to turn the science of solar forecasting from a reactive art into a predictive powerhouse. The third and most tangible leg of our survival strategy is the hardening of our infrastructure. Knowledge and warnings are meaningless if we lack the physical capacity to act upon them. This is the great unglamorous and absolutely essential work of engineering our resilience from the ground up. It means retrofitting our national power grids with robust fail-safes and capacitors capable of absorbing or redirecting the immense geomagnetic currents of a superstorm. It means redesigning our power transformers, the vulnerable heart of the grid, to withstand these electrical deluges. It involves the development and implementation of smart grid technologies that can intelligently segment the network, isolating failures in one region to prevent a cascading collapse that ripples across an entire continent. For our orbital assets, it means designing satellites with more robust shielding, redundant circuits, and the onboard autonomy to enter a protective safe mode at a moment's notice, turning their most sensitive components away from the solar onslaught. And for the vital arteries of the internet lying on the seabed, it means reinforcing the signal repeaters that boost the data stream across thousands of miles, the very components most susceptible to induced currents. This undertaking will be astronomically expensive, a project on the scale of the global highway system or the Apollo program. But we must reframe this cost. It is not an expenditure. It is the single greatest insurance policy humanity could ever purchase for its own future, a premium paid to guarantee the continuity of civilization itself. The cost of inaction, as we have seen, is measured not in dollars but in decades of potential collapse and recovery. Beyond these pillars of action lies a deeper, more philosophical transformation that we must all embrace: the cultivation of a culture of continuous vigilance. The sun's cycle of activity, waxing and waning over 11-year periods, can lull us into a dangerous complacency during its quiet years. The memory of the last great storm fades, budgets for preparedness are cut, and our collective attention drifts to more immediate terrestrial concerns. This is a pattern of behavior we can no longer afford. Vigilance must become as ingrained in our society as our dependence on the technology it protects. It must be taught in our schools, discussed in our governments, and understood by every citizen who flips a switch or connects to a network. We must finally and fully internalize the truth of our environment, that we live on a beautiful, hospitable planet, but one that drifts through a cosmic shooting gallery tethered to a star of immense and volatile power. Our species has evolved to watch the horizon for predators and the clouds for rain. We must now evolve our consciousness to watch our star for flares, to listen for the static of a solar wind, to feel the subtle shifts in the magnetic field that surrounds and protects our world. This is the ultimate goal: to reach a new and mature relationship with our sun. For millennia, we have worshipped it as a god, then studied it as an object. Now we must learn to live with it as a partner, a powerful, dynamic, and sometimes dangerous partner. This is the informed harmony we seek. It is a state of being where our technological advancement is matched, step for step, by our cosmic awareness. A future where a Carrington-level event is no longer a civilization-ending threat, but a severe, yet manageable natural disaster. A time when global alerts are received with calm, practiced efficiency, when grids are powered down in controlled sequences, when satellites are put into hibernation, and when humanity waits out the storm with its core infrastructure intact, ready to reboot and reconnect when the all-clear is given. This future is not a distant dream. It is within our grasp. It is built not with fear, but with foresight. It is forged not by luck, but by labor. Look up at the sun. Feel its warmth on your face. Recognize it not just as the giver of life, but as a constant reminder of the grand, intricate, and powerful universe in which we are privileged to exist. Our journey has shown us the peril, but it has also illuminated the path. The challenge is immense, but the human spirit for innovation and survival is immeasurable. The great star that powers our world has issued us a test. And now, with our eyes wide open, fully aware of the stakes, and armed with the knowledge we have gathered, we have the chance to provide the one answer that truly matters. To work together to build a resilient world and to secure our digital legacy among the stars, ensuring that the light of human civilization is never ever extinguished. The future is not dark unless we choose to close our eyes to the light.